Hello, students. First, who is this video for? Well, this video is for students who are taking or will take a Calculus 1 course that covers optimization. I call this getting ready for optimization. So I will not do any calculus here. What I'm going to do is just set up some functions and solve questions that will help you when you learn optimization. The reason I'm making this video is because I see so many students in Calculus 1 struggle with these types of questions, but the real reason is not the calculus. It is instead the setup at the start. Okay, well, I have 5 examples here, and all of these we will be setting up functions. For the most part, they involve area, volume, and some geometric shapes. Here's the first one. We have a rectangular pen, and one side is against a very long wall, as shown in the picture. We have 500 meters of fencing for the other 3 sides. We want to write the area of the rectangular pen as a function of this side length, x. Well, initially, we know area is x times y. Well, that's not the end of this question because we have to use this part that we have 500 meters of fencing. So 500 meters of fencing would be, well, we have x plus y plus, there's another x right here, which is 2x plus y. Now, how are we going to get area as a function of x? Well, we can use this, that 500 is 2x plus y. We can solve for y in terms of x. So y is 500 minus 2x. And finally, we get area as a function of x would be x times y, which is 500 minus 2x. Now we can write this as 500x minus 2x squared. So this type of example, we will see more. The language that you will learn in the optimization section of Calculus 1, this is called a constraint equation. And so we will see these in some of the problems. It will allow us to write another function, maybe volume, area, something like this, in terms of just one variable. All right. The next one, we can construct a box with a square base and volume 100 meters cubed. X is the length of the side of the base. Now let's draw a picture. Quite often when you get to these types of questions, you want to start off by drawing a picture. So there's my square base, and then here will be my box. Okay, it filled in some certain things, but that's okay. We have x, but this can be anything. We will call it y. Here's my initial picture. So we are told, this is where we will get what's called our constraint equation, but we are told the volume is 100 meters cubed. The volume is x squared y. This is equal to 100. Now, here's the question. We want to write the surface area of the box as a function of x. And then we have this other part which will involve evaluating that function. Well, surface area, here we can look at the picture. This is a closed box. We have area here is x squared. That's for the bottom. We have another x squared for the top. So let me call this surface area. We have 2x squared. That is for the bottom and the top. Then we have 4 sides. You notice this side is x by y. Area is x times y. Okay, x by y. Area is x times y. And similarly, this one and back here. So we have 4xy. Now, our goal of this question is to write surface area in terms of x. And so we can use this to solve for y in terms of x. Y is 100 divided by x squared. Now let's write the surface area. Maybe I will call it S for surface area. S of x. We have 2x squared plus 4x times this y. I don't see in the directions to simplify, but I certainly can take one step here. We have 2x squared plus, this will be 400 divided by x. Now we have this second part. What is the surface area when the base of the box is 2 meters by 2 meters? Well, we want S of 2. This would be 2 times 4 plus 400 over 2. So we have 200 plus 8. We have 208 meters squared. So this is the answer to the second part. When I teach Calculus 1 for science and engineering, it's this part of the question. It's the part we've gone through that students struggle with when they're learning optimization. Next one, we are to build a circular cylinder with an open top. Okay, this will get me started on my cylinder, but it's open, so like this. We are told the volume is 64 pi centimeters cubed. Now, let me go ahead and label this. We have a radius and we have a height. Wonderful. Write the surface area of the cylinder as a function of the radius of the base. Well, and then we will evaluate. So we need to use this. This will give us an equation relating R and H. Well, how do we get the volume of a circular cylinder? You take area of the base times the height. So the area of the base is pi r squared. Multiply by the height. This will be 64 pi. Well, now how do we write surface area? First of all, it's open. Okay, that is an important thing to think about. So we have two pieces. First of all, we have the base, which is pi r squared area. But then we really have, I guess, one side that goes all the way around. So how you can think, or how I think about these, think about cutting and unrolling this. So now I'm going to draw, cut, and we unroll like this. Maybe I should actually draw this in orange. We have this one side that goes all the way around. Here's H, and then you see this and this. Well, they're the same. So this is the circumference of a circle with radius r. We have 2 pi r. Okay, so the area of this one side that goes all the way around is 2 pi r h. So we put plus 2 pi r h. Maybe I'll make this part a little smaller. Now, we want to write the surface area as a function of the radius. Well, as we've been doing in the other questions, we can use this equation that relates the two variables to solve for the height in terms of the radius. Well, let's divide both sides by pi. That's wonderful. And then divide both sides by r squared. We have that height equals 64 divided by r squared. Now we can write our surface area as a function of r. We have S of r equals pi r squared plus 2 pi r times 64 over r squared. And I can simplify this just slightly, especially because I will be evaluating. We get 128 pi divided by r. So this is the answer to the first part. So what we have done so far, That was on a recent final exam in Math 1341, Science and Engineering. Okay, but now instead of optimizing anything, which you will learn in calculus, let's just evaluate. This is our question. What is the surface area when the radius is 8? So we have 64 pi plus 128 pi over 8. So we get 16 pi and 64 pi gives us 80 pi, which you could put that in your calculator and round if you wanted to, but I will leave it exact. We have two more. This one, it's a little bit different than the last two. This one was on a recent final exam as well, at least the setup part. We won't be doing the optimization part. So let me draw a picture for this. So we have, maybe this is length 24 inches. This is length 36 inches. And then we have removed these little x by x, x by x, x by x, x by x. So let me put down my iPad for a moment. What's going to happen here? Well, you're going to fold up the corners and it's going to make a box. My picture is not perfect, but that's what will happen. So you're going to fold here, 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 and here, and it will make a box with an open top. Now, what do we need to do here? You can see, in fact, maybe I'll try to sketch the box. The height of the box will be x. And then we have this length, which would be here. You notice this length is 36 minus 2x. So here we have 36 minus 2x. And then we have this length, which is here. This length is 24 minus 2x. 24 minus 2x. Now, that was the hard part of the problem. And it wasn't easy, but that's why we're going over this together. So now we just need to write the volume as a function of x. Okay, this we can do. The volume as a function of x. Well, we can take the height and then times the area of the base. And you can multiply all of this out if you'd like, but it says no simplification needed, so I will just leave it. Okay. Last example, a rectangle is inscribed in the upper half of a circle with radius 1, as shown below. And then I just remind you that a circle with radius 1 is defined by the equation x squared plus y squared is 1. I mean, technically, the entire circle would be like this. We just have the upper half. Okay, we want to write the area of the rectangle as a function of x. Very nice. Let's start labeling. Well, here's x. And here is y. Now, we get this point here, which is the corner of this rectangle. It's also on this circle. So that tells us that x squared plus y squared equals 1. We have y squared is 1 minus x squared, and y, well, it's a positive square root of 1 minus x squared. We want to write the area of the rectangle as a function of x. First of all, the area, length times width, but this is 2x. It's x plus x, and then we have times y. Now, as a function of x, we get 2x times this, the square root 1 minus x squared. And this example, it also completes these questions. So as I mentioned, well, and you can observe, we did no calculus here. It was in setting up functions. Very useful when you get to the applied optimization topic in Calculus 1. Thank you so much.